Class 3 arc flash hazard indicates an arc flash potential that could cause serious injury or damage to equipment within 18 inches of the source. It requires the use of a 40 cal per centimeter squared personal protective equipment, commonly referred to as PPE. A Class 4 arc flash hazard signifies an arc flash potential that could cause serious injury or damage to equipment within 36 inches of the source. This requires the use of an 80 cal per centimeter squared PPE. While there isn't a formal extreme danger classification defined in electrical safety standards, it likely describes arc flash hazards that surpass the severity of Class 4. These hazards can result in severe injury or fatality. 575 volts can indeed create significant arc flash risks, especially in older facilities utilizing fuse-based protection. Fuse protection can permit high fault currents, which consequently lead to higher arc flash currents. It is advisable to firstly review the study results with the vendor to clarify the specific hazards and their classification. Secondly, implement appropriate mitigation measures such as installing arc flash mitigation devices, upgrading to higher rated PPE, or retraining staff on arc flash safety. Thirdly, consider upgrading the electrical system to reduce arc flash hazards, such as replacing fuses with circuit breakers or installing arc suppression devices. The National Electrical Code (NEC) Article 110.16 provides guidance on arc flash hazards and PPE requirements. The Institute of Electrical and Electronics Engineers (IEE) Standard 1584 provides more detailed information on arc flash mitigation. Arc flash is a dangerous phenomenon that occurs when an electrical fault creates a high-energy explosion. This explosion can release tremendous heat, pressure, and toxic gases, posing serious risks to personnel and equipment. Understanding the factors that contribute to arc flash hazards and implementing appropriate safety measures are crucial for preventing injuries and ensuring workplace safety. The severity of an arc flash hazard is determined by several factors, including the voltage level, available fault current, and clearing time of the overcurrent protection device. Higher voltage and fault current levels increase the energy release during an arc flash, while longer clearing times allow the arc flash to persist for a longer duration, increasing the potential for damage and injury. The classification of arc flash hazards into different classes, such as Class 3 and Class 4, provides a standardized way to assess the severity of the risk and determine the appropriate level of PPE required. These classifications are based on the incident energy, which is the amount of heat energy released during an arc flash at a specific distance from the source. Incident energy is typically measured in calories per square centimeter, cal per centimeter squared. The higher the incident energy, the greater the potential for burns and other injuries. PPE plays a critical role in protecting workers from the hazards of arc flash. Arc-rated clothing and equipment are designed to withstand the heat and flames generated during an arc flash, reducing the severity of burns and preventing ignition of flammable materials. The selection of appropriate PPE is based on the arc flash hazard classification and the specific tasks being performed. It is essential to ensure that workers are properly trained on the use and maintenance of PPE. In addition to PPE, several engineering controls can be implemented to mitigate arc flash hazards. These controls aim to reduce the likelihood of an arc flash occurring or to minimize the energy released during an arc flash. One common mitigation strategy is to reduce the available fault current. This can be achieved by using current-limiting fuses or circuit breakers, which quickly interrupt the flow of current during a fault condition. Another approach is to install arc flash mitigation devices such as arc flash relays and arc suppression systems. These devices detect the presence of an arc flash and rapidly de-energize the affected circuit, minimizing the duration of the arc flash and reducing the potential for damage. Upgrading the electrical system can also significantly reduce arc flash hazards. Replacing fuses with circuit breakers can provide faster clearing times and reduce the available fault current. Installing arc suppression devices can further minimize the duration of arc flashes. Regular maintenance and inspection of electrical equipment are essential for identifying and addressing potential arc flash hazards. Loose connections, damaged insulation, and other equipment defects can increase the risk of electrical faults and arc flashes. Thermographic surveys can be used to detect hotspots and other signs of overheating, allowing for proactive maintenance to prevent equipment failures. Training and awareness are crucial components of an effective arc flash safety program. Workers should be trained on the hazards of arc flash, the proper use of PPE, and the procedures for working safely on energized equipment. Regular refresher training should be provided to ensure that workers stay up to date on the latest safety practices. An arc flash study is a comprehensive assessment of the arc flash hazards in an electrical system. This study involves collecting data on the electrical system, including voltage levels, fault currents, and clearing times. This data is then used to calculate the incident energy of various locations throughout the system. The results of the arc flash study are used to determine the appropriate arc flash hazard classifications and PPE requirements. The study also identifies areas where mitigation measures can be implemented to reduce arc flash hazards. The NEC Article 110.6d requires that electrical equipment be marked with information about arc flash hazards, including the arc flash boundary and the required PPE. This marking helps to ensure that workers are aware of the potential hazards and take appropriate precautions. IEEE Standard 1580 fault provides detailed guidance on arc flash hazard calculations and mitigation. The standard includes equations for calculating incident energy and arc flash boundary, as well as recommendations for selecting appropriate PPE and implementing engineering controls. The extreme danger classification, while not formally defined, highlights the importance of addressing arc flash hazards that exceed the typical Class 4 levels. These high-energy arc flashes can pose a significant threat to life and property and require specialized mitigation strategies. In such cases, it may be necessary to implement multiple layers of protection, such as arc flash relays, arc suppression systems, and remote racking devices. Remote racking devices allow workers to operate circuit breakers and other equipment from a safe distance, reducing the risk of exposure to arc flash hazards. These devices are particularly useful in situations where the equipment is located in a hazardous area or where the potential for arc flash is high. The information discussed should be taken in totality and not as a sole source of information as it relates to the overall hazard. Each individual situation should be reviewed by qualified personnel that can take into consideration the overall safety for the application. Factors such as environmental, location, and the age of the equipment can have a bearing on the overall safety of the hazard. Furthermore, the location of the facility in Florida can be a consideration, with humidity playing a part in the outcome of an electrical event. As temperature increases, conductor resistance increases, but not as significantly as humidity. The rise in humidity increases the chances of condensation forming on insulators and conductors, which causes the impedance to decrease and promotes higher short-circuit currents. Short-circuit currents need to be considered when calculating the proper protection coordination.